Hope everyone is being safe and staying healthy as we go into round 2 of our social distancing. Today I'm going to go over the systems of equations note sheet. I know you guys have a filled in copy available on Google Classroom. I'm just going to kind of fill it in with a little bit of explanation of what's going on here. So what is a system of equations? All right, we know what an equation is. It has the equal sign. A system just means that there are two or more, equations. And for what we're doing here, those are going to be linear. We're going to be looking at linear equations. All right, but that doesn't mean that you couldn't have a quadratic and a linear. Everything that we're going to look at is going to be like these guys. So what is the solution to a system of equations? We're looking at the ordered pairs, those points, that make both equations true. So the ordered pair, that xy coordinate at which the lines intersect. All right, so we have 3 different types of ways that lines can show up on a graph. All right, the first thing with a system, if we have 2 equations, they can cross one time. So if they intersect, they're only going to intersect once because lines are straight. All right, so this right here, because they only intersect one time, there is one solution. So your answer would be an ordered pair x, y. Remember, x, y, alphabetical. Now here we have parallel lines, Will these lines ever cross each other? No, so there's never going to be a coordinate that'll be on this line that'll also be on this line. So for this, we have no solution. I have a robin that is fighting his reflection in my kitchen mirror or window. Loud. All right, so no solution. We can use that symbol with the circle and the line all the way through. Now here we have identical lines, They end up being the same thing. You know, when you start simplifying, and everything goes down to the same slope and the same y-intercept. Right? This has every point on this line because it's like they're stacked. If it works up here, it's going to work down here. So there's an infinite number of solutions. And for that, we can use the infinity symbol, that sideways 8. So solving these by graphing, all right, we want to make sure that everything is in slope-intercept form. So we're looking for y equals mx plus b. All right, remember m is our slope, so that's the rise over run. And b is our y-intercept. So for number 1, our top equation here, y equals x minus 8. So when we're graphing slope-intercept form, we want to put our dot on our y-intercept, which is at negative 8. So I'm going to go from 0, 0, down 8, 1, 2, 3, 4, 5, 6, 7, 8. Put a dot. And then my slope, I don't have a number here, so how many x's are there? 1, so that means it's 1 over 1. It's positive, so I want to make sure it's increasing over time. So I'm going to go up 1 to the right 1. And I'm just going to do it a few times, all right? Or I could go down 1 and to the left 1. Whenever we're making graphs of lines, we need to make sure we use a straight edge, all right? I'm going to use this pad of Post-it notes here. And we want to make sure that our line goes all the way across the graph. All right, as you're doing these on IXL, it'll automatically do that for you. Right, but if I want to see where they intersect, I'm not sure where that's going to happen. So if I take it my line all the way across the grid, right, I'm more likely to make that original line more accurate than if I make like a little short stubby line and then try to extend it later. Let me do that yet. All right, so now graphing our second line. Okay, +1 is our y-intercept. Okay, this time our slope is negative. So as we read, okay, from left to right, we need to go downhill. Okay, and it's a ratio over 1. So we're going to go down 1, 2 to the right 1, or up 1, 2 and to the left 1. And we can repeat that process a couple of times, right? Make sure our line goes. I like to kind of keep doing it until it crosses my other line, because I've discovered that a lot of times these things are going to cross at integer answers. All right, and then if my line's a little wonky, takes care of it. All right, so does this have one solution, no solution, or infinite solution? All right, well, these lines are intersecting, so it's going to have one solution. So I'm looking for the ordered pair for this point. So I have to go 1, 2, 3, all right? Then down 5. Well, that 5 needs to be negative. Mistake in your notes here. It says -3, -5. That should be a positive. All right. So there's the idea, okay? If they're in slope-intercept form, I think we should be pretty good to go. All right, I'll let you guys, you can work on 2 if that's your jam. Yeah, I'm gonna slide over to one where it's not in slope-intercept form. So number 3 up here. All right, we've got -3x plus y equals 8. All right, in order to get y by itself, I just need to move this -3x. So remember, we have to do the opposite. So opposite of take away 3x, it's going to be add 3x. So it's going to be y equals +3x plus 8. Now we're in slope-intercept form. All right, same thing here. We gotta move that -x. So y equals x minus 2. Okay, now we have them in slope.